What if dark matter has its own physics? Imagine, for a moment, that everything you can see, touch, taste, and feel, every star, every galaxy, every atom in your body, adds up to less than 5% of the universe. Now imagine that the other 95% isn't just empty stuff floating around. What if it's a whole second universe layered right on top of ours, with its own particles, its own forces, maybe even its own version of chemistry? What if dark matter isn't a single boring ingredient at all, but an entire hidden world we've been completely blind to? That's not science fiction. That's a serious idea physicists are exploring right now. Let's explore why this matters. According to NASA and the Planck mission, ordinary matter, the stuff of stars, planets, and people, makes up only about 5% of the universe. Dark matter accounts for roughly 27%. The rest, around 68%, is dark energy. For decades, the simplest assumption has been that dark matter is one kind of particle, cold, sluggish, almost completely antisocial. It doesn't shine, doesn't reflect, doesn't bump into things. It only seems to whisper through gravity, holding galaxies together like an invisible scaffolding. But here's the question that keeps a growing number of physicists up at night. Why should dark matter be simple? Look at our side of the cosmos. Ordinary matter isn't just one particle. It's a riot of complexity. Quarks, electrons, photons, neutrinos, atoms, molecules, chemistry, biology. We have 4 fundamental forces and 17 known particles dancing together to build everything from raindrops to redwoods. So if our 5% is this elaborate, why would the other 27% be a single, lonely particle drifting through space? That leads to a fascinating possibility. Maybe dark matter has its own physics. Physicists call this idea the dark sector, or the hidden sector. The basic concept is breathtaking in its simplicity. Imagine a parallel set of particles and forces that are largely invisible to us, not because they're hiding, but because they don't interact with our forces in any normal way. They have their own version of electromagnetism, perhaps mediated by a hypothetical particle called the dark photon. They might have their own strong force, holding together composite dark hadrons. They could even have their own kind of charge that only matters to other dark sector particles. Think of it like 2 orchestras playing in the same concert hall, but on different frequencies. Each one hears its own music perfectly. Neither hears the other. They share the stage, the same space, the same gravity, but the sound waves of one are silent to the other. And here's where it gets really wild. If dark matter has its own forces, it could have its own structure. There's a serious theoretical proposal called dark atoms, in which heavy, dark protons and lighter, dark electrons bind together to form stable, neutral particles. With dark electromagnetism, those dark atoms might form dark molecules. With dark molecules, you could, in principle, have dark chemistry. Some physicists, like Lisa Randall and her collaborators, have even proposed that a small fraction of dark matter could cool, lose energy, and collapse into a thin rotating disk inside our Milky Way. A kind of ghostly second pancake spinning right alongside the stars we know. They call it double-disk dark matter. Sit with that for a second. The galaxy you live in might have a hidden disk you'd never see, even with the most powerful telescope ever built. Some theorists go even further. If dark matter can self-interact and dissipate energy, could it form dark stars, dark planets? And if you really stretch the speculation, though physicists are careful to label this as speculation, could there be dark biology, a whole shadow ecosystem evolving by laws we don't share? Astronomer Avi Loeb has mused about this possibility, suggesting that if dark life existed, we wouldn't notice it the way we don't notice neutrinos passing through our bodies by the trillions every second. To be clear, there's no evidence for dark life. But the laws of physics, as we currently understand them, don't immediately forbid it. That alone is something to marvel at. So what's the catch? Why isn't this the lead story on every science website? Because the universe has already given us some powerful clues that limit how much physics dark matter can have. The most famous comes from a place called the Bullet Cluster, two enormous galaxy clusters that collided about 150 million years ago. When they crashed, the hot gas in each cluster slowed down and got tangled up in the middle, glowing in X-rays. But the dark matter, mapped through gravitational lensing, sailed right through, ending up far ahead of the gas. That tells us something profound. Dark matter, on the whole, barely interacts with itself. If it had a strong dark force pulling it together, it would have piled up in the center too. It didn't. So mainstream dark matter has to be mostly quiet, mostly simple, but mostly it isn't all. There's still wiggle room. Maybe a few % of dark matter could have rich interactions, while the bulk stays dull. That's why ideas like partially interacting dark matter survive. The dark sector might be like an iceberg, with the boring tip showing in our gravitational maps and the interesting structure hidden below the surface. How could we ever find out? This is where it gets exciting. Experiments at the Large Hadron Collider in Switzerland are actively hunting for dark photons and other hidden sector particles. Detectors buried deep underground, like those in Italy and South Dakota, are listening for the faint thump of a dark particle bumping into an ordinary atomic nucleus. Astronomers are studying the rotation curves of dwarf galaxies, looking for signs that dark matter inside them behaves differently than simple cold dark matter would predict. Some recent observations of small galaxies with unusually flat cores actually fit better with self-interacting dark matter than with the standard picture. It's not proof, but it's a hint. And here's the thing that gives me chills. If even one of these experiments lights up, if we detect a dark photon, or a dark force, or a particle that doesn't fit the standard model, we won't just have solved the dark matter mystery. We'll have opened a door into an entire second universe of physics. We'll have discovered that nature was twice as inventive as we ever guessed. So when you look up at the night sky tonight, remember this. The shape of every galaxy you can see is sculpted by something invisible. That invisible something might be a single, simple particle. Or it might be a thriving, complex realm with its own laws, its own structures, maybe even its own history. We don't know yet, but we're closer to finding out than we've ever been. If this idea bent your brain a little, hit that subscribe button so you don't miss what comes next. Drop a comment and tell me, if dark matter does turn out to have its own physics, what would you most want to know about that hidden world? I'll see you in the next one.